Today in this video we will discuss about the expression for fringe. In the last class we already discussed what is meant by interference of light and Young's double slit experiment, and in the Young's double slit experiment how he obtained the expression for fringe width that we are going to discuss. Okay. Interference pattern. Expression for fringe width. So how he obtained the expression for fringe width? So first of all we can draw the diagram. A narrow slit is illuminated equally. We can see that so the source slit here behind this a single monochromatic source of light is kept. So through the slit those light is coming. So when the light is entering this region, these two slits S1 and S2, they have kept equidistant from the source slit. You can see that they have kept equidistant from the source slit, so that we can say that these two slits S1 and S2 are acting as coherent slits. Okay, from these lights will be proceeding. So those light will superimpose in this region, and to observe the interference pattern, a screen is kept which is at a distance d from the two slits, and the distance between these two slits is small. Okay. So small d is the distance between these two slits. It will be in the range of millimeter range, and capital D is the distance between the slits and the screen, and that distance will be in meter range or meter or like that. Okay. Now we have to find the condition for constructive and destructive interference. Already we discussed the condition for constructive interference is given by n path difference is equal to n lambda, and the condition for destructive interference is given by path difference is equal to 2n minus 1 lambda. Okay, so we have to find here what is the path difference, and that path difference should be equated for constructive or destructive interference. Accordingly, we can get the expression for condition for constructive and destructive interference in Young's experiment. Okay. So here, this is the center of the screen. So we can mark it as O. So from the center, we are considering a point P. From the center, we are considering a point P which is at a distance x from the center. Okay. A point P is considered which is at a distance x from the center of the screen. Okay. Now we have to see what is the condition for constructive interference. For that we can see the path difference . So we can mark it as these points as A and B. So we can write the condition for constructive interference as this is P So we have to find the path difference. So how to find path difference is which is more S1P or S2P, because from S1 and S2 waves are traveling. So which distance is more? No doubt S2P is more. So we have to find the path difference as S2P minus S1P in terms of these known quantities. Okay. For that we are considering the triangle. From triangle, this triangle S1AP, we can write S1P square equal to S1P square equal to S1A square plus AP square. Okay. And what is S1A? S1A is D, capital D square. What is AP? From O to P is X and OA is D by 2. So we can write X minus D by 2. Okay. Again we can consider the triangle S2BP. We can write S2P square equal to S2B square plus BP square. S2B square plus BP square. And what is S2B? S2B is D. So B square plus BP is from O to P is X, and here this distance is D by 2. So we can write X plus D by 2. Okay. Now we got S2P square and S1P square. Now we can find S2P square minus S1P square. So that is equal to D square plus X plus D by 2 the whole square minus D square plus X minus D by 2D. Okay. So D square, if you expand, you can see that here if you expand you will get X square plus XD plus D square by 4. Here also if you expand you will get X square minus XD plus D square by 4. So this X square, D square by 4, X square will get cancelled, D square by 4 will get cancelled, and capital D square also will get cancelled. So that you will get S2P square minus S1P square equal to XD minus XD, which is equal to 2. S2P square minus S1P square, we will get it as 2XD. Now what we have to find? We have to find S2P minus S1P. So that can be written as A square minus B square, we can write it as A plus B into A minus B. So we can write S2P minus S1P into S2P plus S1P equal to 2XD, or we can write S2P minus S1P is equal to 2XD by S2P plus S1P. Okay, or we can write S2P minus S1P is equal to 2XD divided by 2. So you may think that we are substituting S2P as D and S1P as D, that's why we are getting it as 20. It is not so. If you can check that by substituting. For example, this one, capital D has 1 meter and this has 1 millimeter. If you substitute and if you find S2P square and S1P square, okay, or S2P and S1P, you can see that it is very closer to, if you find S2P plus S1P, that is very much closer to 2. Okay, that error is but a difference. If you take S2P plus S1P as 2D, or separately if you find that error will be 0.0005 like that, very small percentage of error will be there. That's why for good approximation, we can take S2P plus S1P as 2D, but we cannot take it as S2P is equal S2P minus S1P, which is equal to XD by D. Okay, so we can write path difference equal to capital small xd by d. Okay. Now we will discuss the condition for constructive and destructive interference. Okay. So here we got the expression for path difference. Now we have to find the condition for constructive and destructive. So now we will discuss the condition for constructive and destructive interference. Constructive interference. So already we discussed the condition for constructive interference is when path difference is equal to n lambda, where n is equal to 0, 1, 2, 3, etc. That is the condition for constructive interference. So we can write xd by d is equal to n lambda. Since already we considered the central point will be no doubt it will be of maximum intensity, which corresponds to n is equal to 0. No, in that case, both the waves from S1 and S2, they are traveling equidistant to O, so that will be maximum intensity. So we can write here, we can start from n is equal to 1, 2, 3 onwards. Why we are taking so? Because for this path difference is 0. Okay. So we can write x is equal to n lambda d by d, where n value varies from 1 to 3. Why we have not taken 0? Because already the central n is equal to 0 corresponds to the point O, that is equidistant from S1 and S2. For that path difference will be 0. Okay. So this is the condition for constructive interference. So those points which are at a distance which satisfies this condition, that will be of having maximum intensity. So we can write, instead of x, we can write xn is equal to n lambda d by d. So first maximum, where it will be other than central maximum. Central no doubt it will be maximum. Other than central maximum, first maximum comes when n is equal to 1, which is lambda d by d. Which means from O at a distance, lambda d by d, that will be maximum intensity. Next maximum comes at 2 lambda d by d. Third maximum comes at 3 lambda d by d, and so on. So that is the condition for constructive interference. Okay. Now we can see what is the condition for destructive interference. So what is the condition for destructive interference? So the condition for destructive interference is path difference is equal to 2n minus 1 lambda by 2. Path difference is equal to 2n minus 1 lambda by 2, where n is equal to 1, 2, 3, etc. Here path difference already we calculated xd by d. So we can write xd by d is equal to 2n minus 1 lambda by 2, or we can write x is equal to, or xn we can write 2n minus 1 lambda d by 2. Okay. So this is the condition for destructive interference. Whichever points which are at a distance from this, by satisfying this condition, they will be having minimum intensity. Okay, or we can say it will be of dark. Okay, it will be of dark, perfectly dark, and this will be of bright. So this is the condition for constructive and destructive interference. Now we can obtain an expression for fringe. Fringe width means it is the distance between consecutive. To find the fringe width of a dark fringe, we can say it is because alternate bright and dark fringe will be there. Okay, so central point will be maximum intensity. Next, dark fringe, again bright, again dark, again bright, like that. Alternate bright and dark fringes will be there. So to find the width of dark fringe. How to find the width of dark fringe? The separation between the consecutive bright points, that will be of dark fringe. Okay. Fringe width means the separation between the consecutive bright or dark fringes. The separation between consecutive bright or dark fringes, that is known as fringe. Okay, so we can find the fringe width of dark fringe. How to find? Here you can write. So fringe width is written as beta. So beta fringe width of dark fringe we can write XI nth fringe minus XN minus 2. What we can substitute? Beta is equal to XN is n lambda d by t, the nth fringe, and n minus 1 lambda d by t. But you will get n lambda d by d will get cancelled. You will get lambda d. So this is the fringe width of which one? Fringe width of dark fringe. Now we can find fringe width of bright fringe. How to find that consecutive? If you find the difference between the consecutive dark fringe, you will get the fringe width of bright fringe. So here also you can find fringe width beta is equal to xn minus xn minus 1. So that is equal to 2n minus 1 lambda d by 2d minus 2n minus 1 minus 1 lambda d by 2d. If you simplify again, you will get fringe width as lambda d by 2. So you can see that whether it is bright fringe or dark fringe, it is immaterial, both are having equal width. Okay. So width of bright fringe and dark fringe are same, that is given by beta is equal to lambda d by d. So this expression we have to do. We have this expression for fringe. So fringe width is given by lambda capital D by small d. What is lambda? Lambda is the wavelength of light used. Capital D is the distance between slits and the screen, and small d is the distance between two slits. Okay. Clear? Now we can find what is the width of central maximum. Width of central maximum. So what is the width of central maximum? Here first step, dark point will be there. Here also first dark point will be there. What is the condition for dark point? We can write n is equal to 2n minus 1 lambda d by 2d. So when you substitute n is equal to 1. So if you substitute n is equal to 1, what you will get? x1 is equal to lambda d by 2d. So here also it will be at lambda d by 2d. So total width of central maximum that you can write, if you are representing it as fringe width, that is equal to 2 into x1, which is equal to 2 into lambda d by 2d, which is equal to lambda d by 2d. So here also you can say that this all fringes are of equal width, whether it is central fringe or whether it is bright fringe or dark fringe, is not a matter. All fringes are of equal width. Okay, so the linear width is given by beta is equal to lambda d by d. Now we can find what is the expression for angular width. So angular width is equal to angular width beta is equal to the linear width divided by separation. Angle is equal to arc length by radius. So here linear width we can consider it as the arc length, and radius we can take it as d. So beta by d. So we will get lambda d by d, which is equal to lambda. So you can see that all fringes, their angular width is also same. lambda by d, where lambda is the wavelength of light and small d represents the distance between two slits, and capital D is the distance between slit and screen. Okay. Now, one last case we will discuss when the entire apparatus is immersed in a liquid. Entire apparatus is immersed in a liquid. If the entire apparatus is immersed in a liquid, what will happen to the fringe width? So, fringe width is given by lambda into capital D by small d. Capital D will not vary if it is immersed in liquid, small d also will not vary. Then, what is the thing only that varies is wavelength. Okay, and new wavelength we can write beta dash. So, new fringe width can be written as lambda dash into d by d. Or instead of lambda dash, we can write lambda by n into d. Or we can write lambda d by d is the actual fringe width. So when it is immersed in a liquid having refractive index n, it is the refractive index of liquid. Refractive index of the liquid. So you can see that fringe width will be reduced by 1. Okay. So depending on that whichever medium it is immersed, accordingly fringe width will be varied by 1 by n times the actual fringe width of those fringes in